Most games will save some data of players. For example, in our shooting game, should we save the player's shooting percentage, total score, and other information? Where is this information saved? If it is saved on the user side, there will be a problem. The user can modify the data by himself, and the data is also easy to leak or lose. In addition, if all players are to be ranked, it will be quite troublesome. Therefore, most important data will be saved on the server side. Saving user data on the server side involves network issues. This is the network communication and cross-end parameter transmission we want to understand in this class. You can see this picture, which is a typical CS architecture. The mobile device used by players when playing games is a client. The important data of players is stored on the network server, that is, the server side. To store player data on the server, you must first establish a connection. NetClient and NetServer can be used to establish a connection. You can query our API or help documents when you need it. In addition to saving data, you need to establish a connection with the server, and there is another situation that also requires it. And this situation is more common in online games. That is state synchronization. Everyone sees this picture. For example, in a multiplayer game, player A moves to a certain external device. How does player B get the position of player A in real time? Similarly, how does player A get the real-time position of all other players and update it on his client? In this case, our server is a multi-terminal data synchronization center. All players need to send their information to the server, and then the server synchronizes the information to the client. It should be noted that in order to avoid the confusion of double-end parameter transmission and cause abnormalities in the game project, the server scene and the client scene need to be different scenes at all times. Another reason is that when the project is released, the server will run on our server, and the client actually runs on the player's mobile phone. So, from this perspective, the server scene and the client scene should also be separated. SandMod servers will be divided according to the game, but not limited to the game division. That is, a game may be associated with multiple servers at the same time, and the server bound to the game is automatically assigned by the Blockman Go platform, so developers do not need to manage the parameter transmission of different servers and other issues, and can be regarded as all players of the game on one server. No matter what the situation is, the first step is to establish a connection between the client and the server. Let's do it together. First, we create a new server scene. Name it Server Main Scene. Double-click to open. Since the server does not need to render and display, the camera and light nodes can be deleted. Then, create a new empty node. Name it Network, which will be used to mount the script of the network service later. Create a new folder in the Scripts folder, and name it Network. Used to store network-related scripts. Remember to save the server scene. According to this diagram, we need to write at least one client handler and one server handler. First, create a new TypeScript file in the network folder and name it GamServer. Mount it to the network node and double-click to open it. Add relevant code in the onStart method, used to listen to the client's connection request. When a client's connection request is detected, a netConversation object will be automatically generated to store the client's basic information. We can send messages to the client through this object. In the network folder, create another TypeScript script and name it GamClient. Create a new empty node in the main game scene, and name it Network. Then, mount GamClient to this node and act as a client. Open GamClient and complete the request logic for the client to connect to the server. We have already written the server according to this diagram. To establish a connection, the client must send a connection request to the server. Then, when the server receives the request, it will return the corresponding message to the client. If the client connects to the server, the callback function will be executed. The callback parameter flag value of true means that the server has been successfully connected and the handshake is successful. At this time, other game logic can be implemented. Here, we output the connection success information. Next, let's test the establishment of the connection between the client and the server. The first step is to start the server. Click the menu file, Start Server. Select the server scene in the pop-up dialog box. Then click Start Server and a black window will pop up. You can see the relevant information about the server startup in it. The second step is to start the client. Just like the previous game test, just click Run in SandMod engine. You will see the output of the server later. We are giving you demonstration or testing needs, and will output on the server. Before the actual project goes online, you should remove all outputs. After going online, server_ID will have a value. You will also see the corresponding output information of the client in the editor. In addition to outputting our test information, it will also output information such as the server port. In this way, we have established a connection between the client and the server. Next, how to send and receive messages between the client and the server. In the code just now, the server has sent a message to the client. Next, we receive this message on the client. Save, run the server first, and then run the client. You can see the message sent by the server in the console window. How to handle the message sent by the client to the server. After the client connects successfully, send a message to the server. Then receive the message and process it on the server. Save and run. It is found that there is output on the server. If we want to send some data from the client to the server in real time, we can process it in the onUpdate method of the client. For example, we continue to send messages to the server for a period of time. After reaching a certain length of time, output the number of messages sent and then disconnect. Save. Run. If you want to send the data on the server to the client in real time, just process it in the onUpdate method on the server. Save. Run. For easier observation, we can comment out the onUpdate method on the client. Then on the server, add a variable to output the number of messages sent when the conditions are met. Save. Run. So far, we have basically understood the establishment of the connection between the client and the server, and the sending and receiving of messages. With these as a foundation, we can implement some simple applications later.